Hello, today we're going to talk about all the different ways that weather patterns and global climate can be changed by different factors. So this is coming from chapter 4, but also we're going to start to get into chapter 20 today, which is all about global climate change. So when we're talking about this, it's important to understand that the ocean and the atmosphere are constantly interacting with each other. Neither one is a closed system. They both depend on each other. The wind affects the ocean currents, and we saw that last time when we were talking about the wind causing upwelling. The ocean temperatures affect the wind, so they're going to cause areas of high and low pressure. They're going to affect your weather patterns. The Gulf Stream brings that warm water that's also going to bring warmer weather with it. Hurricanes are going to be impacted by water temperature, things like that. So this is a constant interplay between the ocean and the atmosphere. One of the things we need to talk about today is severe weather. So severe weather is usually occurring whenever you have those fronts that we mentioned before colliding. So air masses are moving and they're basically hitting each other. And when you get cool, dry fronts colliding with warm, humid ones, some pretty crazy things can happen. This tends to happen the most in the spring and in the fall because that's when our jet stream, which is that air that's traveling just on the edge of the stratosphere up there, really starts to move. And as this jet stream moves in the spring and the fall, it starts to make these fronts collide more and more. So one of the things that can happen because of that, when these things collide, is we can get huge thunderstorms and things like that popping up. And a severe thunderstorm basically happens whenever you get that cool, dry air mass coming in and colliding with a warm, humid one. And because they collide, you get this huge convection current here. And that warm, humid air, because warm things rise, it's going to rise up above the cool front coming in. And it's going to create this super strong convection current. And it's going to go straight up. And this is going to cause a severe thunderstorm. In addition, you have this warm land underneath it that's going to warm it even more and cause it to bounce even more up. And as this happens, it's going to transfer this heat up to the upper levels of the atmosphere. And the water vapor is going to start to cool once it gets up here. It's going to condense, form a cloud, and this is going to happen very, very quickly if you have a big difference in temperature here. As you have that storm rising into the freezing air, sometimes you get ice particles being created way up here on the edge of the stratosphere. And those ice particles basically keep collecting more and more drops and getting bigger and bigger, and when these ice particles collide, they can actually bounce off each other and rip pieces of the other one, and this can cause an electrical charge. So this is actually how we get lightning. It's a result of these really strong convection currents. You get this electrical charge, which causes a lightning bolt, and then the sound waves you hear are the thunder that's associated with thunderstorms. Again, all from these air masses colliding and that strong convection current. So sometimes when you have a severe thunderstorm, if the conditions are just right to start taking that convection current that was going straight upwards and actually start it spinning a little bit because of what we call wind shear, it can actually start to form a funnel. And if you get this rotating funnel of air, that can become a tornado. It's only going to become a tornado if it actually touches down on land. Sometimes you will get these funnels up in the thunderstorms, but they won't touch down, so you won't have a true tornado. But when you have these winds that are coming at opposite directions from each other, they start to shear into each other and kind of push each other around until they form this spiral. And that warm convection current pushing up this spiral intensifies that tornado even more. So it's really just a form of a thunderstorm cloud. Then we have something called a hurricane, which again is kind of similar, but a little bit different. This is a very, very large storm, and in order for it to be considered a hurricane, it has to have wind speeds of over 118 kilometers per hour, which is about 73 miles per hour. This is happening most often when you have those strong trade winds that are coming on over the tropics, picking up moisture over those warm tropical waters. And that warm air, again, is going to try to rise upwards. And the Coriolis effect that we've already talked about is also going to make this storm spin at the same time. So what we get are these spirals of storms, thunderstorms, around and around each other with this huge warm moist air convection current coming right up the middle, up the eye. And this causes that spinning shape that you see. Now, depending on where these are, they're called different things. So if they're over the Indian Ocean, these are usually called cyclones, or sometimes in other tropical areas, you'll hear them referred to as cyclones as well. Hurricanes are what we call them here in anything that forms over the Atlantic. If you're talking about things that form over the Pacific, we're usually calling them typhoons, but they're all essentially the same type of storm. And these are forming when that warm air is being sucked up. You're getting these huge storms that start to circle around each other because of the Coriolis effect, and it will start to gain speed if it's going over warm water because it's picking up more and more air that's sucking it upwards and spiraling it even faster and faster. So there's a lot of things that can affect the strength of a hurricane, but the number one biggest factor is that ocean water. The warmer the ocean water, the more likely it is to become a full-fledged hurricane. And the longer it stays over it, the higher degree of a hurricane you'll get. Now, there's also a lot of evidence that how much rain there has been in areas of Africa can influence the number of hurricanes we get. So the more rain there is, tends to be more hurricanes because you have more humid air coming along the Atlantic there being brought over by the trade winds. When you do have a dry year in Africa, not only is there less humidity in the air that prevents them, but there's actually been a few studies that say that the dust that gets blown off of the deserts there will actually prevent the water vapor from condensing into these storms as well. So dry years in Africa are good for us in terms of preventing a lot of these dangerous hurricanes from developing. And then the last thing that really influences them is something called an ENSO cycle, which we'll talk about in a second. So an ENSO cycle stands for El Nino Southern Oscillation, and you've probably heard of El Nino before. And this is where we get most of those year-to-year climate changes. Some years you have a really warm year, some years you have a really cold one, some are very wet, some are very dry. That's usually because of these El Nino oscillations. And basically the pattern that this follows is you get an El Nino year 1 to 2 years at a time, and then it'll go back to its normal pattern for 3 to 7 years in between those El Nino periods. This is basically what happens during El Nino. So the trade winds that are usually very strong and are constantly blowing across the Pacific are going to start to weaken. And because those trade winds weaken, that will allow the water right under them to start to warm up. Now, because those winds have such an influence on ocean current, it will actually cause those ocean currents to slow or stop, especially the surface currents that are really affected by the winds. So that thing we talked about, upwelling, last time, which normally brings up all these nutrients from underneath, is going to stop. And because of that, the water isn't being turned over. The water's not being cycled. So fish and other organisms that live close to the surface and depend on these nutrients coming up often die during these time periods because there's no nutrients coming up to support them. It also affects the global air currents, and it leads to some pretty unpredictable, unusual, and dangerous weather. So here's basically what happens in a normal year. You have these nice strong trade winds blowing in this direction around the equator, and they're bringing that warm water out away from the shore of South America so that that cold water can come upwards and upwell so that you get those nutrients. In an El Nino year, those trade winds are so much weaker that you get a lot more convection cells, and instead of it pushing all the way across, it has these little areas here and there where you have different storms. This basically stops that whole process of upwelling so that it's no longer circulating that ocean water. It's just one long warm area in the ocean. And again, when you stop that upwelling, you're going to get less nutrients up here. You can see what happens to the temperature. The temperature is much more uniformly warm. You don't get those cold waters. And you're going to see lots of fish basically dying off because of this. Now, the reason why it's called El Nino, it's actually named little boy after the Christ child, because this warming condition comes up on Peru just before Christmas. So it's not a really good Christmas present because it devastates their fishing areas right about that time. And you can see that all of the different weather patterns that can result as an effect of El Nino. So some areas get wetter, some areas get drier, some will get warmer than usual. In 1997-98, we had a particularly bad El Nino period, and this one caused 20,000 deaths and more than $33 billion in property damage worldwide. You had heavy snow in the western U.S., there were ice storms in eastern Canada, torrential rains in Peru, Ecuador, California, Arizona, and western Europe, droughts in Texas, Australia, and Indonesia. And Indonesia was hit so hard by these droughts that they actually lost an area the size of New Jersey to forest fires. So these can have some really severe effects on global weather and climate patterns. So one of the ways that people keep track of these patterns is using these TRITON arrays. So there's these buoys out in the Pacific Ocean where scientists will actually measure the weather patterns and try to predict this. And this could give us up to 6 months in advance to kind of plan for these El Nino patterns happening. Now, after an El Nino event, you will have a La Niña event that goes along with this. So this means little girl instead, and it's kind of the opposite. So the Pacific Ocean here is going to become unusually cool instead of unusually warm, and those trade winds, instead of weakening, they're going to become extra strong. And this affects weather patterns in really unpredictable ways. We tend to get wetter weathers in the Pacific Northwest, warmer weather in the southeast, drought in the southwest, and more hurricanes in La Niña years. And in that spring of 1998, the eastern Pacific actually cooled almost 12 degrees Fahrenheit in just 20 days. So you can hopefully see how much of an impact that would have had. Right, so this is your typical La Niña conditions instead. So you can see pretty much just the opposite of what El Nino is doing. One of the other things we want to think about is global climate change. So not just weather patterns and how they're being impacted, but remember, we are enhancing this greenhouse effect by all of the different chemicals that we're putting out into the atmosphere, mostly CO2, but many other things. And if you look at the global temperatures in the last century, they have been rising considerably, and on average, and this is looking at the entire world, we've gone up 1.5 degrees Fahrenheit. That doesn't sound like a lot, but you have to realize in certain areas it's gone up quite a bit more. And also, even that small rise can have really unpredictable effects on both weather and so there are a lot of different effects that this climate change could have, but for now I want to focus on the one that is most related to what we've been talking about. And one of the things that people are really worried about is that it could shut down that global ocean conveyor that we were talking about last class. And this has happened before. It's happened in other climate changes where you've removed that deep ocean current because of abrupt climate change, and it has actually shut down in less than a decade. If this were to happen now, it would cause Europe to go into an ice age. It would also mean that the oceans wouldn't hold as much CO2. So that means if there's not as much CO2 in the oceans, there's more in the atmosphere. So this is another example of that positive feedback loop where something that we're doing is just going to cause it to get warmer and warmer and warmer. And the results of that are very unpredictable. It is hard enough to predict what's going to happen with the weather and even the climate long term as it is. With all of these factors that we've been talking about this unit, you can see it's very complex. So you add in something like that and all of your plans and all of the ways that you understand that the world works kind of goes out the window, and that's part of the concern about the whole thing. All right, so next class we're going to start to talk about how these precipitation patterns and climate patterns change as a result of these things and try to hopefully piece together all of these different things that are affecting our ocean and atmosphere. See you tomorrow. Bye-bye.